Once students have some basic understandings about fractions, they're ready for fraction computation. Let's take a look at a released test item. This item deals with multiplication of fractions. Ina, how do you suggest our students approach a problem like this?
Well, of course, they can always use the traditional algorithm, but sometimes that's problematic for students. But if they have good number sense, what they can think about is 2 3/4 times 3, and they know that 2 3/4 is close to 3, so they can think of this as 3 times 3, which is 9. And know the answer at the most is going to be 9, but they have to compensate for the amount they added on, which was a 1/4 for each of the three groups they have. So they're going to have to subtract off a total of 3/4. So 9 and take off the 3/4 is going to give us 8 1/4. So that's one way. Another way is to think about distributive property. That if I think about 2 3/4 as 2 plus 3/4, then I can look at this multiplication as two different multiplications. I can do 3 times 2, which is 6, and then three groups of 3/4. And if students aren't clear doing that, they can think about it as 3/4 and 3/4 as being 1 1/2, and another 3/4 to that, which is 2 1/4. So I'm going to add 2 1/4 onto that, and again, my answer is going to be 8 1/4.
Very nice. Can you help us look at another released test item?
Sure.
This one's about addition.
If we look at this problem, we're going to be adding 3/4 and 1/8 together. And if I look at the four possible answers on the test, we can eliminate 2. Students should be able to eliminate 1/2 and 1/3, just because I'm starting with 3/4, which is larger than 1/2, so it has to be larger than 1/3. And then I'm going to add 1/8 to it. Well, if I look at getting 1 whole, and I start with 3/4, I have to add a whole 1/4 onto that. But all I'm adding is 1/8. So my answer has to be 7/8. So if I have some good number sense, then I can solve this problem without doing actual computation, but looking at the possible answers and see which ones make sense.